Operations on sets. What kind of operations can we do on sets? The union of sets, two or more, contains every single element that appears in any of the sets. We use the word or to describe the union because if it's in the first set or the second set, or if there's a third one or the third set, then it is part of the union. So it only has to be in one set or another. The intersection of sets has the elements which are in every one of the sets. So if it's intersection of two sets, then it would be the elements that are in both of these sets. If it's an intersection of three sets, it would contain only the elements which are in all three sets. The complement of a set would be the opposite of the set. The complement is going to contain all of the elements from that particular universe for that particular problem, which are not in that set. So the complement of A contains all the elements that are not in set A. The difference of two sets is the first set with all of the elements that are also in the second set taken out. Now the elements that are in both sets would be the intersection of the sets. So the difference is the first set with the intersection of the two sets taken out. Let's do a few of these and see how it actually works. Now, in the particular font that I'm using here, and I don't have any other option, the U, capital U, and the U for the union, I don't have two different notations I can use for that. So you're going to have to read whether it's a verb or the name of a set by the context, as so often happens in any class, including math. If we want to look at the union of set A and B, that's going to contain any element in A and also any of the elements in B. Anything that's in either A or B will be in the union. The union is going to have the A, C, and F from A. That's our starting point. Now, to this, add any elements that are in B that we haven't already mentioned. So we've got D and E to add in. And these are no longer in alphabetical order, but that doesn't really matter. What would the intersection of A and B look like? Now, I don't have any way to type the intersection, so I have to draw it in. But the intersection of A and B would be the elements that are in both set A and set B. If we look at the two to compare them, we see that we've got an A that's in both and an F that's in both. So the intersection of A and B is going to be the set of A and F. What about A minus B? What about the difference of these? We would take set A, which is A, C, and F, and remove anything from that which is also in set B. Notice that A contains the little a, the C, and the F. B contains the little a, so that's going to have to go. D doesn't matter, E doesn't matter, F. So A minus B, set A, subtracting any elements that are also in set B means we have to take out the A and the F, and that's going to leave only element C. So notice that the difference and the union and the intersection all result in three different things. What if we needed to do the complement of A minus B, not A minus B. Well, we cannot do that until we figure out what would be in not A. So not A. If A has A, C, and F, and the universe we're talking about has A, B, C, D, E, and F, then what is it not in A that's in the universe would be the B, D, and E. So we've got B, D, and E. Now we're going to subtract set B, which is, A, D, E, and F. So the complement of A minus anything that's also in B would leave just the B, lowercase b. So to get the complement of A minus B, first you have to know what's in the complement. Then we're going to subtract anything that's in B. What if this had said the complement of A minus the complement of B? Well, we've already figured out that the complement of A complement is going to be the set of B, D, and E. Now we're going to need to know what B complement is. B complement is going to have anything that's in the universe here that is not in B. Well, B actually has 4 of the elements out of the 6, so this is only going to have 2, right? And that's going to be B and C. So if we take the complement of A and remove anything that's in the complement of B, what's it going to leave? We've got B, D, and E from A complement. We're going to take out B and C. Well, there already isn't a C there, so we have to take out the B. That's going to leave D and E. And that's got an extra little symbol there that I'm not able to take out at this moment. This is one problem I've had some questions from students about. They want us to use the Venn diagram to represent what portion would be the complement of B union A union C. So the first thing we have to do is figure out what A union C would be. A union C, when I clicked on the Venn diagram, this part came up, so it's got the paint. A union C, do I have to do these one at a time? Here's set A. Here's the part of C that isn't already painted. So these 2 circles would represent A union C. B union A union C would be to add in all the parts of B that I haven't already colored. So that's just going to be this. So this is B union A union C. The complement of this would be only the part that isn't already colored. So if I now color the outside and uncolor well, not sure how to do this. But if these three circles colored are A union B union C, then the complement of that would be the outside part here. Make sense? So the outside part is the complement of the union of the three sets, which I did work out in order, but A union B union C is going to be the same regardless of order. If I take the union of A and B and then I add C to that, I'm going to have the same as if I had the A added to the union of B and C. And so the complement of that would be the part of the universe that is not in A or B or C. What about the intersection of C with A minus B? Here's A. If we subtract the parts of A that are in B, that's going to leave us this part. This would be A minus B. Now the intersection of C with A minus B is the part of the set which is in both set circle C and the part that has A minus B. So if here's A minus B, and here is C, then the intersection of these is going to be this little part right here. So what I would have to do would be to erase everything here and then come back and color in just this little part. Let's take a look at this problem. This one is kind of hard because it has so many elements. The universe is everything from all the integers from 1 through 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, nothing missing. So everything from 1 to 13. A has these numbers, B contains these, C contains these. To get the intersection of C minus A and C minus B, I would take set C and subtract everything that's in set A. So C minus A is going to consist of, if I take C and take out anything that's in A, I will take out a 1, not there. I will take out a 3, okay. 5, okay. 9, gotcha. 10, yes. 12 and 13. So that's going to leave me the 4, 6, 7, 8, and 11. Now I need to get C minus B so I can get their intersection. So C minus B, I start over here. C minus B is going to be C with anything that's in B removed. So 2 isn't there, 3, got it, 4, yes, 7, take that out, 10, take that out, 12 and 13. So that leaves me 5, 6, 8, 9, and 11. Now the intersection of C minus A and C minus B is going to be the set of values that are in both of these two sets. So 4 is not in both, 5 is not in both, 6 is. This is in the intersection. 8 is in the intersection. 11 is in the intersection. So the intersection would be 6, 8, and 11. If it had asked for the union, then I would just copy down the first set and then include anything that was in the second set that wasn't already written down. So the union of these, which they're not asking for, granted, but if it said the union of these, I would write down one of the sets, 4, 6, 7, 8, and 11. That's the first one. And then I would add the 5. 6 is already there, 8 is already there, 9, 11 is already there. So this would be the union. This is the intersection. Just saying. Okay, so that's how these work. You just got to pay attention to the details, and you have to understand the notation. You have to understand the vocabulary. You have to know how to do an intersection, what it is, how to find the union, because you have to know what it is. The difference, take anything that's in the second set that's also in the first set out. So it's basically the first set minus the intersection of that in the second set. The complement is anything that's in the entire universal set that isn't in that set. And there's various assorted layers. Order of operations, if there are parentheses, make sure you follow any parentheses. You have to find complements before you can do anything with them. And then once you've got all the sets, including complements if necessary, and you've done all the parentheses, just work it from left to right. Takes a little practice, but it's not that bad. It's just a game. Enjoy. Bye.